All right, so let's take a look at this system of equations. Still, three unknowns, three equations, and really you can choose whatever you want to in order to get something to cancel. So if you say, I like getting the x's to go away, fine. If you're a y person, go for it. It doesn't matter. Now, I think I'm going to start with the x and just see what happens. So if I look at equation 1 and 3, I see they both have x. So if I just do equation 1 minus equation 3, I'm going to get the x to go away, which is great. So x minus x is 0. 1y minus 3y is negative 2y. Negative 1z minus this positive 3. So negative 1 minus 3 is negative 4z. And then 1 minus negative 5. So 1 minus minus becomes 1 plus. So we end up with 6. Now, I need to get another x to cancel. So here's what I'm going to do. If I multiply the first equation times a negative 2, and then I add that to the second equation, that should be enough to get my x's to go away. So just keep in mind that if I multiply this guy times negative 2, you would have negative 2x minus 2y plus 2z equals negative 2. And so that's what I want to combine with the second equation. So negative 2x plus 2x, 0, it goes away. Combine the y's. Negative 2y minus y is negative 3y. Positive 2z, negative 8z is negative 6z. And then negative 2 plus 11 is positive 9. All right, so we got a new system, two equations, two unknowns. Let's see what we can do here. Well, let's try to get the y's to go away, right? So if I want to do that, let me just erase this stuff out here for right now. If I multiply the top equation times 3 and the second equation times 2, just by crisscrossing those coefficients, well, they would both give me negative 6y, but I need one of them to be positive, one to be negative. So let's make the second guy negative, and let's see what we get. So the top guy is negative 6y minus 12z equals 18. The second equation is positive 6y plus 12z equals negative 18. So when I combine these equations, the y's go away, the z's go away, so we'll have 0 on the left, and 18 minus 18 is 0. But this is a true statement. And since it's true, that means there are an infinite number of solutions. So we've got to figure out how to get those solutions. So very similar to what we did when it was just two equations and two unknowns, you're going to pick one variable and you're going to let that one be the main variable, and you build everything else off of that. So I would say let z be any real number. Okay. So let z be a real number. Well, then I need to figure out what y is in terms of z. So we can take this equation here, let's say negative 2y minus 4z equals 6, and solve it for y. So negative 2y equals 4z plus 6. Divide everything here by negative 2, which means y equals negative 2z minus 3. All right, so we have z is just going to be this, y is this, but we need to find a representation for x. So we're going to go back to the first equation. It said x plus y minus z equals 1. If I get x by itself, x is equal to negative y plus z plus 1. We want x in terms of z. So we make the substitution with the y. So again, use parentheses for substitution. That's going to be negative 2z minus 3 plus z plus 1. So this is 2z plus 3 plus z plus 1, which means x in terms of z is 3z plus 4. And you would have had the same outcome if you had plugged that into any of the other original equations. It all would have simplified to be x equals 3z plus 4. So if you were to write, say, an ordered pair for this, or ordered triplet, so it's going to be of the form, of course, x, y, z, where x is equal to 3z plus 4, y is equal to negative 2z minus 3, and then z is going to be any real number. Now, as we showed before, again, you can pick z to be anything. And what you're going to find out is that you'll have a complete ordered triplet, and that would then work for all three of those equations. So let's just pick something to make sure that that we're not lying about anything, right? So if z were to equal, let's make it simple, right? If z were to equal 0, then x would equal positive 4 when you plug in 0 for z. And then y would equal negative 3. So you would have the ordered triplet 4, negative 3, 0. And if you were to substitute that in to all of those original equations, everything would work out right. You could pick another one. So suppose z equals, let's say, negative 3. Then that would mean that x equals, if I plug in negative 3, so plug it in right here, that'd be negative 9 plus 4 is negative 5. And if I plug negative 3 in here for z, for the y, we get 6 minus 3 is 3. So another solution would be x is negative 5, y is 3, z is negative 3. So we have an infinite number of solutions. So if you were tasked with finding at least one solution, you could just do that. Cool beans. All right, up next, word problems, because everybody loves a good word problem.